Good evening.
Am I wrong in thinking this is like we can scan the whole body and see what's going inside more effectively than we've ever done before?
Yeah, that's correct. So this new scanner, which is called a PET scanner, which stands for positron emission tomography, is a type of scanner we've had at Peter Mac for 25 years for scanning patients with cancers, but this is a next generation device. So the way this technology works is we inject tiny amounts of radioactivity, and then the scanner is very sensitive and it can reconstruct three-dimensional images to track cancers wherever they are in the body. The current scanners we use scan about 25 centimetres, so about a standard ruler, and then the patient moves and you would do another 25 centimetres, and you do that 5 or 6 times, and then a computer stitches those images together and you can scan the whole body, which is a little time-consuming. This next-generation device can scan 1.3 metres, so really, half the body in one go. So this is quite revolutionary because it increases the sensitivity and the speed literally by an order of magnitude. So 20 years ago when I started with this technology, a PET scan would take an hour and a half to scan one patient. And with this scanner, we can do one patient in under a minute. So that's quite a revolutionary change.
Yeah. So is it something that's going to pick up things that are going wrong? I'm trying to use the simplest terms because you're the expert here. In terms of what's going wrong and where cancers are developing, can it pick it up more quickly or more effectively?
Exactly. That's what this technology aims to do. So if you're diagnosed with a cancer, most patients nowadays will have one of these PET scans, and the standard radioactive tracer we use is a radioactive sugar, and tumours are growing, so they use a lot of sugar, and therefore the tumours light up very brightly on the scan, and we can localise them. And so this can be used both to diagnose cancer earlier or also in someone that has cancer, work out if it's spread, and that helps your surgeon or your oncologist work out how to manage you best, because it's obviously critical to know how far the disease has spread. And a revolution has happened in the last decade where we've moved beyond just using a radioactive sugar, and we can now use radioactive substances that hone into specific cancer types. So one that was pioneered at Peter Mac in Melbourne is a scan for prostate cancer called a PSMA PET, and it links onto a very specific protein that's located on prostate cancer cells. And this allows us to really hone in on prostate cancer, visualize it in 3 dimensions in the whole body. This is a scan that 10 years ago was a research scan, and now it's a standard of care all around the world. And if you're diagnosed with prostate cancer, you're likely to have one of these scans. And that technology is now expanding to really every single cancer type with advances in chemistry and our ability to make molecules that are very specific for your cancer type.
Am I correct that you mentioned prostate cancer? We know people get checked regularly, and I'm thinking prostate cancer, I'm thinking brain tumours. There are things that can be growing, if you like, within the body before you get the symptoms. So is this going to be a way, before people get symptoms, perhaps to pick up something that might be in their body, which raises the question whether you do the scan when you haven't been diagnosed with cancer?
Yes. Look, no scan is perfect. So you want to be careful scanning too many normal people, because there can be findings that can be alarming but turn out to be nothing, and that can cause unnecessary procedures and anxiety. But done correctly, yes, this can diagnose cancer early. So coming back to the prostate cancer, you may go to your local doctor and have your blood test done for prostate cancer, your PSA, and if that's elevated, you may then go on to have one of these PET scans to try to work out, do you have prostate cancer and do you need any intervention? So done correctly, this is going to improve screening for particular cancers, and it's really important to pick up cancers early because, that's the best way to cure it, by cutting it out. Now, if it's picked up too late, then it becomes an exercise in tumour control rather than cure.
Look, before I get to the question of the radioactive substance, because people have asked about this, and I know there are protocols surrounding all of that, but is this also the kind of thing that's going to give us more of an idea of what the cancers actually do to then get to that point where we might be able to cure some of these things, or work out, for instance, where brain cancers come from in the first place and stop it happening?
Yes. With this technology, we can not only visualize tumours, but we can try to characterize them better, because tumours or cancers can come in different grades. So they can be slowly growing or they can be very quickly growing, and they need to be managed very differently. So we can, a little bit like doing a biopsy, taking a pathology specimen, we can image how aggressive the tumour is, or we can try to image the immune response to the cancers. So there's a whole variety of different ways we can not just look at the cancer, but how the body's responding to the cancer with this technology.
Okay, and with this PET technology that's now being developed, is it going to be available widely? Do you get referred to it? Can you go and have it if you've got some suspicions? What's the protocol around that?
Yeah, so there are more than 120 PET scanners around Australia. So just about every big hospital now has a PET scanner. But this 1.3 metre scanner from GE Healthcare is actually going to be the first of its type anywhere in the world. It's actually a pre-commercial installation that they're installing at Peter Mac. This is quite unique because usually when they have a new generation device, they would put it in a big centre in the USA or a big centre in Europe. But, they've chosen to put it in Peter Mac. That's really a marker of the strength of the entire team at Peter Mac that can really use this new technology fully and show its new applications and how it'll improve both cancer diagnosis and cancer treatment.
And so in terms of getting more of these things, they're obviously quite expensive. A lot of the equipment is. How does that work? Is that up to health departments, funding, even listing it on schedules as well?
Yes, so currently a PET scan is on the Medicare schedule, so you can get a rebate for it. The technology is always improving. So this actually in some ways reduces costs because we can use the scanner more efficiently. Like I said a little bit earlier on, a PET scan used to take 90 minutes to scan one patient. Now we can do it in 1 minute. So that means on one device you can scan many more patients in a day. This brings down the costs significantly, but is also much better for patients because, coming to the hospital and when you could be working, patients' time is important too. So this is revolutionary in decreasing the amount of time that it takes to do one of these scans.
Yeah, and look, Doc Ross, I think, discussed this with us last week because we had a few questions. And just on the question of the radioactive substances that you use here in terms of the safety of that, in terms of the amount of it that goes in, the number of times, what can you tell us about that?
Yes, so we are using radioactive substances, but we're using them in extremely tiny amounts, which don't have harmful effects. So for the radioactive sugar scan, as an example, we inject about 1/20,000th of a single granule of sugar to get one of these scans. So it's an absolutely tiny amount. It's almost a homeopathic amount, but the scanner has an extraordinary sensitivity for detecting these radioactive substances, so we don't need to use much. And another advantage of this bigger scanner is we can actually inject lower amounts of radioactivity because the scanner has about 30 to 50 times the sensitivity of our current generation scanners. So not only are we using low doses of radiation today, but on these next generation devices we can even go to half that dose or even a third or a quarter.
Yeah. I know we use the cliche about looking for a cure for cancer a lot. It's so refreshing to talk to someone who's involved right at the coalface of trying to do that, and this sounds like a fantastic step forward. So I appreciate your time tonight. Thank you so much.
Yeah, no, this is really great for cancer care in Australia, pushing boundaries forward, and a big thank you to the Australian Cancer Research Foundation that's, found the money from philanthropy to fund this device at Peter Mac.